So good evening, guys. Thanks for joining the meetup number 23rd by Kaggle Days Meetup Delhi NCR. I hope that all of you are doing well and staying safe at your home. So we had the opportunity of bringing up another meetup in with you so that you can learn in these tough times. So today we have very much talented two young, I would say, AI machine learning experts kind of stuff. You might be seeing them as an expert in the years to come. So we just try to get hold of them and learn something from them. So today we would be having a session on a primer to generative adversarial networks by Ayush Singh. He's a 13-year-old Microsoft certified AI engineer. So like we will just definitely try to understand how things go there, but we will also try to learn on the topic that he would be presenting. After that, we would be having a session on importance of projects versus number of certificates by Prashans Dixit. He's a 16-year-old Kaggle 2x expert. We are so much excited to host both of them. Once both of the sessions are over, we will be having a Q&A session together where you can put up your questions, or maybe I can ask some of the questions which audience provided to us beforehand. I will try to ask those questions to Prashans and Ayush, and we are much excited about the event. I hope that all of you are too. So I hand over this stage to Ayush for his session. So here you go.
Okay, can I start the
Yeah,
presentation?
sure. Yeah.
Just verify me if it is visible. It is visible?
Yeah.
Yeah.
Okay, so in this live session, I will be talking about GANs, means generative adversarial networks. But don't worry, it's a very easy concept. I'll be breaking it down into kind of an easy concept. Don't worry. So first of all, I would like to talk about myself. Maybe you are curious to know about. I'm Microsoft certified Azure AI engineer and Azure data scientist. And also, I also own a YouTube channel newer. As it is a small YouTube channel just now, but I have a good end-to-end courses over there. Just now working on a GANs, NLP, natural language processing, and computer vision, but more specifically focusing on generative adversarial networks and computer vision. So I think you got an overview. So without wasting too much of time, let's get into the content of this kind of a session. So first of all, I would like to give you some of the applications of generative adversarial networks. What actually generative adversarial network examples are. So examples can include, like, let's say you use image filters in your life. So just like this, it uses GANs over there. So let's say you have a classification problem and you have a less amount of data. So you can generate some more data set. Like here you can see that we have a MS data set where we have generated some more examples that looks like real, just like the previous one. So we have generated some more data points as we can generate anything that we want. And also we can generate faces that has never been existed on the earth or on the planet. These faces that you can see has never existed on the earth, and they are generated using generative adversarial networks. In 2014, GANs started taking over by Ian Goodfellow, and till now, GANs have emerged till now, and it's amazing. Currently, research is going on, and I think that GANs are some of the interesting topic to work upon. Let's see some of the more applications that makes GANs amazing. Image to image translation, I've written short. So image to image translation. What do you think? What actually image to image translation is? Let's say we have a running horse, and it can convert into a zebra. But before that, I have here that we give input kind of a simple kind of photo of our sky, and here is a ground truth. You can see over here that we have a ground truth, and this is our output by the GANs that looks like realistic image. So we give the input, there's a y hat, and we get the output which is absolutely amazing. Maybe you can use GANs in your kind of a drawing project. So you just make a simple outline over here that you can see. Just make a simple outline, give it a GANs. You can see where we give input to the GANs, and the GAN will output this realistic image. It looks like real. Okay, so just hand draw something. If you want to fool your teacher of drawing, so you can do this kind of thing. Means just draw a hand drawn picture, and then you can get an output which looks like real. Okay, so Now I want to talk about text to image translation. Again, this is one of the most versatile kind of a application that, let's say you imagine that you wanted to see some bird sitting on the branch. So just you write a bird sitting on a branch and GAN will convert that into an image that was actually bird sitting on the branch. So here is some examples. So you can head over to this. You have written the example like this. As I can show you, the small bird has a red with features that fade from array to grid. You have written that, and GAN will generate these much of examples. And it's also take care in the second example that a bird is black and with the green has a short kind of a at a beak. So it can take a look at that and it will generate the images with its specific features. Okay, so this is a cool thing that you might think. Another application is video to video translation. Video to video translation means I have taken one example that, let's say there is a running horse and you can convert into a running zebra. As you can see, the horse is here, which we give as an input to our GANs, and GAN will generate the output using that input. Okay. The next application is again to video translation. It is a making Mona Lisa back to life. So you make Mona Lisa back to life. Either you just give this image or to the GAN, and GAN will make Mona Lisa back to life just by making his face like a deep face. And it's kind of interesting, I think so. So let me verify once I'm live or not. I'm live.
Yeah, you're live.
Okay. So till now, these are cool applications of generative adversarial networks. And I think there is a lot more. GANs are emerging technology like NLP, computer vision. So I'd highly recommend to explore this tech to learn more about. But in this session, I will be also talking about its overview of generative adversarial networks. So what we do, how we generate some training examples. So what we do, we kind of a machine, we have two neural networks. The first one is generator, the second one is discriminator. Okay, so GANs consists of two neural networks, mainly known as generator and discriminator. And if you don't know about neural networks, please kindly bear with me. Neural networks are just like a stack of layers consisting of a head-on layer, input layer, but just don't worry about neural networks if you're getting confused. Let's say you have two players, generator and a discriminator. Okay, so you have two players, that is generator and a discriminator. Let's talk about generator. Generators train to generate the fake data that looks like real. What I've said, train to generate fake data, like it will generate the fake data, means just have shown you that the output of GAN. And then discriminator will classify that example as a fake or a real. If it is fake, then it will go back to the generator, generate some more examples. Then it come back to the discriminator. Discriminator try to classify, then it gives to the feedback, and again kind of thing. So here, generator is trying to fool the discriminator. Generator is trying to fool the discriminator by making realistic images, by generating fake real images that looks like real but is actually a fake image, but that looks like real. And discriminator is trained to classify that generator generated image from the real. Okay, so what you do in generator and discriminator, you give a real data to the discriminator, but you do not show any kind of real data to generator. And I will talk about this. I will take this argument just in a second. So generator try to fool the discriminator, and discriminator try to do not be fooled by the discriminator. And in this way, they compete with themselves. And this is how they'll learn both. But it's the overview. If you haven't understood, don't worry. It's very easy to understand or grasp. So here's the blank sheet. And first of all, I will talk about the whole training process from start to end. So how you generate some fake data from the generator. So you first give the noise vector to the generator, and generator generates some fake example that looks like real. In this example, the generator here is to generate the fake example that looks like real, and discriminator goal is to classify the example as a fake or a real. So here is our generator generated image, and here is our discriminator classifier. So this is a real image and this is a fake image. So generator will classify this image. So it obviously says that, hey, this is fake. I'm not going to take this. So it is fake. Then what it will do, the generator it will give update, it will give feedback, and then in this way. But you might think, why, what is the relation of competition over there? But it might feel intimidating. Don't worry, this if you're not getting, but understand, actually there are two neural networks that could, the generator generates the fake example that looks like real. In this way, it tries to fool the discriminator, and discriminator tries to classify the example as a fake or a real. Okay, so the whole training process of GANs is very easy. So what you do, how you generate some fake examples. You generate some fake examples by giving a noise vector z, and the vector can be n-dimensional. Here I have a 3-dimensional, but in real world we usually take 100-dimensional or maybe 128-dimensional. We take that vector z, a random kind of a numbers over there, and then we give to the generator. The generator will do is generate fake example, generate image from that vector. It can generate like this. It can generate like this. It is kind of an, don't know, just to generate from that vector. Okay, so let's say we denote x star, that generate image. So let's say he has generated this. Obviously it is, and in the first term it will not generate like this. So let's say it is generated like this. Okay, and also, and then what we'll do, we take out our training data. We take this training data that we'll use to train our GAN. This is training data, and we give this training data to the discriminator, but we will not show this training data to the generator. Okay, so we give training data to the discriminator, but will not show to the discriminator. Okay, and this is the case. You are just told to paint something, but you don't know what to paint. By the way, you're expecting it to paint to let's say a dog, but you don't know, but the generator doesn't know what to paint. So in this way, so it generates fake example, then it's give to discriminator, and also we give a real data to the discriminator, and discriminator we classify it, and we take out the classification error using cost function. Might you know that? And then using that cost function, if we will kind of take the partial derivative of our cost function. Mainly the partial derivative is just like this. So there is kind of a it just changes the parameters or the theta that he used to generate some example, or he used to generate the theta using this theta. Okay, so it will use that, it will make use of that, and then we will update this theta using taking out a partial derivative of our cost function. So we'll first take out a partial derivative with respect to discriminator, and then we update the weights of the discriminator, and then we use that partial derivative with respect to the generator, and then we update the weights of our generator. And you might think, hey, what is partial derivative? But you don't know, but you don't have to know about calculus at all. This partial derivative just like this. You simply tweak the theta parameter, and you see how much cost function changes. And if it changes, you update the data. So you update the theta if the cost function decreases. So this is the whole training kind of a process of a generative adversarial networks. Okay, so let's break it down, generator as well as discriminator, to talk about discriminator and generator specifically, the training of. Okay, so in discriminator, what we'll do, we generate this is a fake example. This is a generated fake example. This is a x star, then denoted by x star, and this is a real example. So we give to the discriminator over here, and discriminator then will take out it, classify it, and will compare it with the ground truth and take out a cost function using classification, kind of a classification error. And using that classification error, it will try to update the discriminator using taking out a partial derivative cost function. Mainly, if you don't have a partial derivative, it's just like this. Just something to tweak your parameter and then see if the cost function changes and update that is called the gradient descent algorithm. Okay. So it always try to minimize this error. As you know that we always try to minimize our cost function so that our J of theta should be approximately equals to 0. Okay, so this is over your training process of discriminator. And I'm live just now. Just verify me so that I'm live.
Yeah.
Okay, now we have discriminator, and then we'll talk about generator. The training process of GANs as generator is just the same. Like we take out some noise vector denoted by z in the real world. It can be 100-dimensional. I usually take until now 100-dimensional if I've been biased, and I've also taken 128-dimensional. It matters problem statement. So you have to take care of the kind of a noise vector z. Okay, and it's you filled with random numbers. It is not a big deal. You take a torch or random using a PyTorch if you can do. You use a TensorFlow, you can do that. Okay, so you take out a noise vector Z, and then you give to the generator, and generator generates some fake examples that you can see over here. I've taken that as a fake example, and then it gives to the discriminator. But before that, we take the training set and we then give to the discriminator. But again, I'm saying we do not show the training data. That is a dog over here. We don't show that to the generator actually. Okay, so we give generator, we do not give training data to the generator, but we give a training data to the discriminator as well as the fake data, and using that classify it, take out the error, update the weights of the generator. Okay, so this was simply a process of generative adversarial networks. Okay, so how do we do? We do it for each iteration. And you might think, what is each iteration? It means, let's say you have chosen 100,000 iterations. So you do for 1,000 iteration over there. Okay, so for each iteration, you do all those things. I mean, in first iteration, you take out noise vector, generate example, classify it, update, and update. Then in second, do the same. Third, do the same, and like that. Okay, so I have just highlighted it out. Let me show you once again what I'm saying. Okay, so we have talked about these all, and it seems to be kind of easy that you have understood overview of how actually the GANs training works, and pretty much easy to understand actually how GANs work. So we take out a noise vector Z, we generate using the training examples, and then using the discriminator, we classify it, take it a classification error, update the weights of the discriminator, update the weights of generator, and then again, specifically for a discriminator, we give real data, fake data to the discriminator, and discriminator then classify it. We do for the same process of generator, we take out a noise vector Z, it can be any dimensional, we take out a generator that generates fake examples, real data, and then we give to a discriminator, but will not show it to the generator, and then we'll take out classification error, and then we update. We do not take out in case of generator, we take out error, and then we update the weights using the partial derivative forecast function. Okay, so and we do each for whole training process for each iteration, and then you might think that, hey Ayush, when do we know when we have to stop it? Because in here, one is trying to fool it so that the discriminator loss increases, and other wants to, means kind of it's a mini max game. I'll try to make you familiar with what I'm saying. It might seem intimidating or making you confused. Don't worry. So in regular neural network, if you have a regular neural network, kind of any simple neural network, we used to stop training when our development set started getting worse. Okay, so we used to stop at there when our kind of a validation is to started getting worse, or to avoid overfitting so that it cannot learn more. So we stop there to mainly in a validation or a development set. But what in GANs? Both neural networks have the competitive nature. So one networks try to get better and other get worse. What is this to kind of a 1, 2, 3, 4, 8 word says? This says that you have a generator, you have a discriminator. Generator goal is to fool the discriminator by making fake example that looks like real. And discriminator goal is to classify the fake example and the real example. So eventually its goal is to classify the generator generated example and the real example. Okay, so let's say the generator generated more realistic image, and then it gives to the discriminator, and discriminator says, okay, it is good. Okay, it passes, it is real. So discriminator has been fooled by the generator. So one is starting getting worse. So we stop at that point. But there is two conditions. The first condition is the generator starts producing fake examples that looks like real at that point, and a discriminator can randomly guess whether the particular example is real or fake. So in general, generator is the generator who generates the fake example, and the discriminator is kind of a simple classifier that kind of classify the images. Okay. In summary, I can say there are two neural networks, generator and discriminator. they have both competitive nature. One tries to fool the discriminator by making fake example that looks like real, and one tries to not be fooled by the generator by classifying the fake example and the real example. So if here I'm taking a fake example that is generated by generator, okay? And the next one we have is when GAN reaches at the point where neither the neural network are improving, at that point we stop the training process. It's just like a neural networks, okay? This is what a whole thing is there, but I will try to recap some of the things so that you could get a more intuitive understanding of whole GAN training process. So let me recap one more time, and then then I will wrap up. Then I will end up my session. Okay. So here it is. So what actually does? We have a generator and a discriminator. We give noise vector to the generator, and generator generates some kind of fake example, and we take a real example and we give to the discriminator, and discriminator then classify it, and then we take the partial derivative, and then we take and updates the weights. Okay, so this was the basic kind of a process of how generative adversarial networks are. I hope that you will ask questions to me, and I hope that you got a fairly intuitive idea about generative adversarial networks. Okay, so I can stop my screen. Yeah. Okay, so you have got an overview of generative adversarial networks, but if you want to learn more, there's kind of a not much tutorial on GANs just now, but there are a lot more books available. But I did highly recommend that I will be also posting 8 hours tutorial on generative adversarial networks, where I'll be going from very scratch, talking about deep learning kind of thing, like kind of a convolutional neural networks, recurrent neural networks, and then we'll drastically move on, making project-based learning kind of thing, and then we'll a little bit move on. Then we'll talk about pix-to-pix, and we'll cycle GAN and make fun projects like you can convert image to image that you're seeing as an example. That was just a great thing that we'll have. So in this way, you can learn more, or you can head over to any book online if you wanted to. But in the first week of June, kind of a new era, it will be uploaded 8 hours of tutorial. Okay, so that's it for me, and head over to Prashans.
Yeah, thank you, Ayush, for such a brief session on GANs, because there have been multiple sessions where the size of the sessions are too much, but the thing that you covered today is the main agenda of that session, right? That long session. So I really appreciate how you try to summarize those things. We definitely have a question, like a few questions that the attendees have sent us beforehand, so that we can ask you in case they have not been able to join. So we'll definitely try to put those questions at the end. But now we will move ahead with Prashant's session on importance of projects versus number of certificates. Prashant, you can share your screen. In the meanwhile, like if you have any questions, so it's like for both Ayush and Prashant, Ayush would be there till the end of the session, and he would be more than happy to answer a few of the questions. And definitely, I also have a few questions that I will ask both of them. So stay tuned. So Prashant, go ahead and share your screen. Yeah, we can see the screen. Yeah, yeah.
Sure.
Go ahead.
So hello everyone. I'm Prashans Dixit. Welcome you all for the 23rd Kaggle Meetup Delhi NCR. Uh, so I so let's get started and see what I have for you all today. So today's my agenda is to throw some light on the topic importance of project versus those certificates. So without any further ado, let's get started. So first of all, to bring more value to the certificates and then showcase your projects. So what this line signifies is people pay too much exposure to the certificates and all. So in my view, certificates are very much overrated, and and you will see many people showing their small certificates, participant certificates and all. Uh, in Okay, I agree to the point that it's an inner peace to do so. But let's discuss this in a bit, like how and what certificates actually mean and value. So only thing is that don't just jot down all your certificates everywhere. And okay, so rightly said is people put too much value in this title of jobs and the job itself, and same goes with certificates. Like people pay too much value, like they like to share all their certificates, but not the work they actually did. Okay, so next is let's just get familiar with what an ML project is, like machine learning project. So an ML project is supposed to be summary and implementation of all the skills that you have acquired in ML over a period of time. So it generally consists of the model itself, okay, for the problem or the topic, and it also includes the user end part that is called deployment or web app. So the web app allows the user to use and interact with the model. And okay, so this is what we're gonna see next. That is importance of modern deployment. So yes, this is one of the most underrated stuff in ML or data science project. That is importance of modern deployment. So people like everyone should get this thing in their mind that how essential the modern deployment part is. Let's understand this a little more with an scenario where you want to share your one of your project with your non-programmer friends. Let's say a dog versus cat class CN classifier. So are you gonna send him those 50 to 60 lines of code to run? No, absolutely not. So what you will instead do is you will create a web app for the model and deploy it on the cloud. Like you will create a nice UI and you will share it with your friend. So he can enjoy your work and like see your skills, like and see how the images are getting classified. Okay, so there are many popular deployment platforms like Streamlit, Heroku, AWS, etc., and also uh, web deployment frameworks like Flask, Django, and also Merl. So also, many of you would have seen this meme like uh, depicts a dog as a recruiter scolding the applicant, like why he mentioned the local host project on his resume, even if he has not deployed it or posted on GitHub. So make sure this not happens with you, and so in one sense, or the big picture, we can see that implementations and the learning process confer much more value than the certificates you own. So, so next thing is, ever you wondered like why we run behind certificates? So let's answer this question next.
Yeah,
So one
Prashans,
possible
yeah,
reason
Prashant,
would be materialism. Like likes to uh, everyone likes to look for free or paid or look for certificates and instead of the like they should instead look for the how the quality of the course is or how the content is. So what so let's get to know like what is actual value of a certificate. Okay, so actual value of a certificate in my view is motivation. Like if you're keen enough to get the fruitful out of the course or whatever you are doing, and if like so the certificates and also the goodies actually work and also play a role to motivate you a bit. And second important point is authentication. Like it authenticates your skills and the work you did to accomplish it. uh, but the thing is, like, you are not mean enough to get those certificates only, and like you
yeah,
actually participated in it. Yeah.
Prashants, we are not able to see the screen changes. Like we can only see the first screen, first slide. So maybe have you changed the slides, or are you on the first slide only?
uh, is the screen visible?
Yeah, screen is visible. So now it's the end
Is it
slide, right?
visible?
Yeah. So now it's the
Is
first
it
slide.
visible?
Yeah, yeah.
Is it now okay?
Now we can only see the first slide. Try changing the slides once.
Yeah, I'm changing, but how is it like you are not able to see them?
So click on the second slide. Like click on the second slide. Like maybe you can click and we can move that way. Yeah.
Is it
That way
like
we can maybe. Yeah.
okay.
So maybe you can turn off the camera if there is a network issue. No, you can turn off the camera and we can just have with the audio only.
So So what I was talking about was motivation and authentication. So authentication is some like it authenticates your skills and the work you did to accomplish the thing or the course. Only thing is that provided that you are not mean enough to get those certificates only, and you actually participate genuinely, and also you took the fruitful out of it. So okay, see, I don't say that I didn't make this mistake. I did, but actually, I'm trying to let the people know that don't do these mistakes also. And I will also try what I'm saying. Like I will also deploy my old ML and Python projects, and also will try to deploy those like notebooks as a web app. So, in the conclusion, suppose that basic ML project you created somewhere. So really quickly summarizing all the points. That is first is model building on learning process. That enjoy the learning process. Okay, enjoy what you do and don't run behind the materialistic things like certificates or goodies. Second is implementation. That deploy your work on the cloud platform and let it get recognized by others and spread your skills. Third is that showcase. Like now you're good to go to showcase your project on a resume and you can show it to others anywhere and anytime. So then this it brings me into my presentation. Thanks to everyone and over to you, Aaron.
Thank you, Prashans, for like short topic session on this session. So maybe Ayush and Prashans, if network allows, definitely you can put turn on your camera. So thanks to both of you for such an awesome session. So like two things that I can relate to both of you. It's the deployment, right? So like Ayush is a Microsoft certified Azure like certified engineer, right? So like he knows about this deployment kind of stuff. And Prashans also talked about deployment and trying to showcasing what you did, right? Like Prashans mainly try to focus on like whatever you built, whatever knowledge you had. Like let's say you learned that how linear regression worked, how logistic regression worked. The main stuff is now to showcase it, even using Flask, even using Streamlit, try to host it on Heroku kind of stuff. That was the main crux of Prashant's topic. So what do you think, Ayush? Like how much is it easy to shift? Because like maybe folks are too much scared, right? Like first I have to learn machine learning, then I have to learn like how to make that pipelines, how to make that microservice work, and then I again have to learn that deployment. So do you think it's very tough to shift because you have gone through that path, you know that cloud things better? So like what would be your suggestions around that deployment of machine learning applications?
I think machine learning application deployment is kind of underrated. That he said is underrated, but actually this is the important part that you have to deliver to your customers, and then you will get to know actually how it is working, how your model is working. So I think deployment, I think, is kind of a not easy, not too much hard. It is medium. There is a cloud server or Edge or a browser, even a Flask or Django. You can use that. But if you talk about interview preparation kind of in placement kind of thing, it's okay. It's okay that you do with Flask or Django. Then you build a crappy kind of a small kind of a website, or that you integrated using a machine learning into that. But actually, what happens that if you want kind of making your own product, machine learning, that is serious product. So you have to follow the pipeline of machine learning deployment. Means not with deployment, it's a machine learning pipeline. So you first understand this, it is called the scoping. Then you go in the next step, then you kind of take out the data, ask some question about the data. Then you go into modeling, then you talk about deployment, then you talk about, and also you do some error analysis using modeling. So you can tweak something and then you can improve that. Then you give after deployment, then you give to the maintenance, kind of deploy it, then you maintain it, see some errors, because in just now in COVID-19, credit card fraud detection has collapsed because mainly the people who are shopping online, kind of in 20% of people now, 80 to 90% of people started shopping online using credit cards, and they have to retrain the model using the same data. So that is example. So I think not it is too much hard, not it's too much easy, but it is actual the real machine learning engineers do.
Got it, got it. So it's like bringing whatever you did, whatever solution, whatever approach you thought of to the real world service, right? Like because
Yeah,
otherwise that would be only in your local machine and no one would be able to utilize it.
yeah,
So
yeah.
like we just heard the views about deployment kind of stuff from Ayush. So Prashans, how have been your journey? Like how do you think maybe like you are also learning kind of stuff like how to deploy, how to learn those things. So any suggestion around that, like what things one should keep in mind, or maybe your experience around learning about deployment, how does things work, and any suggestions?
Okay, so I not work with like I said that I also made this mistake that I never look for the model deployment part, but at least like things like Streamlit and these tools really quickly help you deploy your model, like create the web app. So people should not be afraid of it or worry about it, like how we can do it, but just learn the things that is very much important. Like these tools really are very helpful. So this was the only suggestion that be consistent with what you do, and yeah, that's all.
Yeah, so got it. So like consistency and kind of passion to learn. So like maybe like the audience can understand that thing from both of you, like 13-year-old and 16-year-old. So that's kind of a youngest speaker we had on our platform. So it's like a lot of this is an example that how passion can drive you, right? Like I was talking to another student, like he's a 7-year-old Guinness World Record holder. He would be also coming on our event. So it's like the passion that all of you share, right? Like all of us as a community share around machine learning and kind of stuff. So keeping around that, how this passion grows. So like both of you might have got a lot from the communities, or might have been benefited from the community. So before the event started, I was talking with Ayush, right? Like he was talking about like how he got a invitation from deeplearning.ai to present on a topic. So like Ayush, would you love to throw your lights on that? Like how have been your journey with communities, and how have machine learning, your journey of learning machine learning, have been boosted with the help of communities?
Yeah, absolutely. But I would like to thank the PDF version books mainly to make me familiar actually what machine learning is, and Andrew Ng to make me familiar actually with how machine learns. So I think it was a good journey. It was I faced the challenges of mathematics, mainly linear algebra, calculus. But I think that calculus is not required that much. But little bit knowledge of calculus is required at research level if you want to do research at machine learning or deep learning. So calculus obviously required. And linear algebra is kind of easy. I not too much easy. Kind of a okay medium level. So I learned from Khan Academy. This is algebra 1, algebra 2, algebra 3. And it is linear algebra. And I'm not going to algebra 3, but algebra 1, algebra 2 I've covered. Then I've gone to linear algebra, cover the most important topics, eigenvectors, eigenvalues, orthogonality, inner, outer, etc. Then I move on to then actually I'm in search of some books, courses. So I was seeing some video on YouTube, but not able to actually grasp the concept. But I see whenever I just randomly gone onto the Coursera from Tricky Man YouTube video that is saying that free course on machine learning. So I've gone to there and then I simply see that started watching the first video. I was sitting in a randomly and see I was it was interesting at that point. Helicopter kind of at MIT was and flying. I was amazed with the power of machine learning. And so at that point, I started from week 1 to week 11. Then I taken a reference book called Hands on Machine Learning with TensorFlow and Scikit-learn. And also I kind of learn algorithm and implement it from scratch, trying to learn from Wikipedia pages, mainly the assumption, because in linear regression is not just about theta 0 plus theta 1 times x1. It is also about interpretation, assumption, Gauss-Markov theorem, which is a history. So you should have to know actually kind of a comfortable with every machine learning algorithm. Although you don't have to know kind of thing like assumption, interpretation, but assumption is obviously required, but it is not required that much to much research level. But I kind of really say that I was interested into that. So I started again from Wikipedia pages, reading each and every line, kind of seeing each equation, because in Wikipedia you don't see coding, you only see kind of past things, and you see some of the text, which is kind of a hard text, means written by a hard text. But if you run background, it's very easy. So I will start from web pages, mainly the Wikipedia pages, then the elements of statistical learning. Although I will not recommend that book to the beginners because it is one of the hardest books that I found that I read till now, being on machine learning, because it actually does not talk about machine learning. It talks about directly to derive this equation. It just experiments that, does its discussion, then it's going to a neural network, which is amazing, kind of is hardest thing that I found, kind of a neural elements of a statistical learning. But you can go the introduction to statistical learning, the one is written by Harvard students. You can head over to that. But for me, it was a good journey till now, and it will be a good journey. It will be full of failure. Kind of I failed sometime. Kind of I also being some succeed sometime, but I failed because of what I was doing, kind of thing, and I learned from that. I don't think that my failure is kind of thing like I fail. I was saying that that is an opportunity to learn something, some real world. So from that, I've seen various peoples. I have seen the world, actually what the world is. I've seen good peoples, bad peoples. I've seen that, and I really see some sort of people ask some people for advice. So I started my Kaggle kind of a one competition. I was a little bit confused actually how the problem statement was. So I thought like NLP competition was there, like I Coleridge initiated. It was kind of non-interesting. I think so. I've struggled a lot, made some baseline models using kind of LSTM, but it was not achieving more accuracy, kind of above 50. It was 40 to 50 in any box, whatever you do hyperparameter tuning. So I think that is too much hard level for me to get into because I was new to the NLP. So it is for hard, but I'm in kind of a competition which is just came away, which is a computer vision. We have to identify COVID-19 detection using the chest radiographs. As I've already worked with that, I'm clearly comfortable. I'm just reading our research papers, kind of preparing the pipeline, how we'll proceed. And but first of all, you have to understand the problem because before going to problem, many of the data science beginners fail due to the not understanding the problem. They directly go into code, they code it, but they didn't get that and they leave that. So that is the kind of a not good thing. You have first to understand the problem, make the full pipeline, how you're going to proceed, take a look at which research papers, how they approach the problem, and in this way it will good to go. So this is all my kind of a journey till now.
Got it, got it. So quite of exciting journey, and you learned a lot of things hard way, right? It was not always easy that it's a smooth path to learn, but definitely while you go through that hard path, definitely a lot of things are learned that you would not have otherwise learned. So Prashans, I was recently watching one of your interview kind of stuff. Like you just came live with someone on a podcast, like I don't know, Kunal Naik kind of stuff. So
Yeah,
yeah. So I watched that. So it's like, how have been your journey? That just to reiterate, because I have been kind of viewing your profile and a lot of good works that you have been doing, and like the circle that you have around data science, machine learning is really kind of motivating. So how have been your journey in machine learning, and how have been like you able to collaborate with people? Like, what were your go-to sources for learning machine learning? Like Ayush told a lot of resources around that. So any pointers around that, your journey and kind of stuff?
like first of all, that that machine learning is something that started the interest of math in me. Like it was just opposite. Like people afraid are afraid of math, but I was good to go with math because of machine learning. Like it's just a thing of passion and curiosity. Then second thing is that I believe in free courses. Like free courses are just like there are many courses that are much more worthy on the YouTube than the paid ones. Like I never ran for any paid course, and then like what to say. Like in the starting, like I was more curious than that. Then the consistency kept me on to learn more and more. Like this is what the fuel of mine was to know more and more about the domain and its core parts. Like next of like what my next aim would be like getting more about data structures and algorithms and also about MLOps and all this stuff.
Yeah, got it, got it. So it's like a kind of exposure to that YouTube videos kind of things, and you learned a lot from that. So like I just appreciate the work that has been going on YouTube. So like keeping in mind, Ayush also has a YouTube channel, right? So like I just watched a lot of videos on his channel. It's like even I learned a lot like around data structures. Like he has certain playlist on data structure, and I even had the pleasure of sharing a problem statement with him that let's try to see like if we can solve it. So definitely he like creators are coming up, and we definitely have champions like Prashans and Ayush like Ayush is definitely putting up great content. Like I even watch it after my internship gets over to understand like okay to revise those data structure algorithms kind of stuff. So good work Ayush around that. And Prashans also, like you just mentioned that how the fuel to learn, fuel to explore certain things kept you going, right? So it's not always that you have to have a goal, very specific goal in mind, that I need to be a machine learning engineer at Twitter, I need to be machine learning engineer at Google. It's like your passion to understand the domain, your passion to understand how these things work kind of stuff. So yeah, kind of good exposure. So like coming to a few of the questions that audience has sent us for Ayush session on GANs. So it's like a lot of the students just fear out, keeping in mind that this is like though the generated images kind of generated results of GANs are really cool, right? Everyone loves them and everyone tries to enjoy with them. But it's like whenever they try to approach this, like they tell, okay, I will learn this next month. I will learn this next month. Let's make this basic clear. Let's make this basic clear. So like the shift from like they have this thing that they are not in a position to go to GANs at this point, like maybe what they tell imposter syndrome kind of stuff, right? So how was like I know that GANs, directly going to GANs would not be the best idea, but definitely like you focused a lot on this, like you should not be a master of that partial derivatives kind of stuff. Just understand how these things work and go ahead. So like those who have this kind of imposter syndrome that studying GANs might not be the best option for me right now. So what would be your suggestion around that, because you also started, and maybe your tips around that?
Yeah, it's kind of a many of the fellows, even I was having that GANs a little bit advanced topic, but I think that okay, you just need machine learning, a good grasp of machine learning, and you just need the basics of deep learning. Means in deep learning, you should know convolutional neural networks. You should know it's easy to understand. CNN is just have some layers. So kind of a you should basics of deep learning and a good kind of medium level of machine learning just to get know how things are working, so you can jump to GANs. But having theoretical understanding is much kind of a good thing, but also practical understanding is also a good thing, so both should be 50-50%. But I think that if the someone is an imposter syndrome, so I will say that don't worry, it's kind of a I have even I just say one thing, that even a 13-year-old can do, then why can't 20-year, whatever the age can to do? Because one person was saying that if you are 13 year, then I have to sit in corner of the room and then cry. So I just say no. You just have to think if 13-year-old can do, then why can't 12-year kind of a 22-year can do? So I just take this definition and there's yes, that makes sense. So I think, yeah, then you just have a grasp of machine learning, a good grasp, and then head over to the deep learning, basics of deep learning, because every book, mainly I will share one the book, which is Generative Adversarial Modeling, kind of deep learning for vision systems. It is from O'Reilly, and also there's one more book, Generative Modeling, kind of that. I will kind of just head over to GAN's book, and then you will see a lot much. But I will highly recommend to go with O'Reilly book and GANs in action if you want to. But GANs in action does not cover too much of deep learning, so I highly recommend to Generative Deep Learning. You will see that they're kind of a good book that I use as a reference. So this was it. It's not too much hard. It is not too much easy. It is again a medium level.
Got it, got it. So like well summarized answer, and it's like any beginner level project that you would love to share with the folks, like because a lot of those attendees they told that maybe try to ask this question because we might not be able to join us live. So it's like
Mhm.
any beginner level GANs, so that
Yeah.
at least they get their hands dirty, because getting the hands dirty is also a big challenge, right? Because once you get into that, definitely, like Prashans also told, like the fuel to understand the domain, to learn more, definitely keeps you going. So any solution or any suggestion around that, like first project, like kind of which they can, which
Yeah. My first project was generating handwritten MNIST digits, improving that model to a rustical level. So the first project you can use that the generating handwritten digits. Mainly, you can use kind of a one hidden layer to that. Either it will generate a very poor example, but some of the digits are convincing. So just start with generating some fake exams, kind of a not fake MNIST with MNIST digit that is already in TensorFlow and Keras library, just a dot data set. You can use that. So it is just start off with kind of a MNIST data set. It will work fine, and then improve that using deep convolutional GAN. Then use some hyperparameter tuning. Then add some dropout if there are a lot of hidden layers, kind of a hidden nodes into that hidden layers. But first of all, if you wanted to get hands on dirty, I'll highly recommend to go with MNIST with one hidden layer. If you don't know much about that, just first chapter, because mainly every book introduces the vanilla GAN, which is called a vanilla GAN, which is just a simple GAN. Means one hidden layer. Maybe some of the books might use DC GAN over there, but using MNIST, there are a lot of tutorials to for scan on blocks as on Medium, or maybe the books you can refer to that, or a research paper by Ian Goodfellow about generative modeling. Because at 2014, yeah, I think I'm remembering the name. So at that point, but research paper is a little bit hard to grasp, because when I started, I read that, but I didn't got that. But after read some tutorials, I've also some other tutorial, but on the first week of June, you will get that. But go with first research paper, and then try to see some blogs where they have made the GANs, coded the GANs, and then simply make a hidden layer. Just try different kind of a data set, like use the fashion data set, or maybe the fashion MNIST data set, or maybe using a celebrity data set, or just use that. But I would highly recommend to go with MNIST with one hidden layer.
Got it, got it. So like kind of great suggestions around getting the hands dirty. So like those were the main questions around that. So keeping in mind, like you both have been in a school, right? Like you both are school students. So it definitely gets very much tough to handle both these stuffs. Both the sides of learning machine learning, then going to school, and you have a pressure there too. So pressures, because you just shifted to class 11th, right? And it's like a certain times it's in India it's like, oh my god, class 10th and class 11th 12th, like you have to prepare for certain competitive exams and kind of stuff. So how have been like your time juggling between these two? Like it's not easy, definitely I know it's not easy, keeping in mind like how much time this building machine learning skills take place, and also studying about this physics chemistry maths in your class 12 11 12. So how have been you juggling? And then I will come to Ayush, like how he juggles with his daily schooling, like so yeah.
So comparing the class 11th with class 10, so in class 10, I was having the advantage of the COVID pandemic. Like I totally used the time to understand all the things, uh, like anyone having that interest could have used that time. So that was something that I used it time. So so coming to the class 11, so it is really very hard to uh, like doing ML or DS with the class 11 studies is really very hard. Like I don't get much time now, so I am only doing such things on the weekends. Also, like don't if you are not getting the time, so just don't uh, force yourself to do so. Whenever like you get time. Uh, Uh,
Just go ahead and learn kind of stuff. Yeah.
uh,
Got it. Got it. So it's like whenever you get time, just don't waste it. And when you have kind of golden opportunities like pandemic lockdowns, hope you are staying safe. Try to utilize that time, and maybe you can utilize that time to somewhat other things maybe useful for your career. So how Ayush have been your journey around juggling this like school and this machine learning kind of stuff?
Okay, I have not jug until now, but how I manage that, because my school is kind of a means have to do. You have to do. There is no can nothing. You have to do. You must to do to pass. So you have this kind of a statement. But I have to not go to school, but have to attend the online classes for 75% plus attendance. But I have never attended that, and I written once kind of thing application that my internet connection is not so much good, so I can't join that. So they said, okay, we will mark you attendance. So because school is at chapter number 1, and I'm at chapter number 10, means kind of a completing the book, and I'm starting with a class 10. So how can I kind of a basic kind of what is rational number? It is this kind of thing. I'm just a class 10 now, and why I'm going to study again class 9 as I've turned from 2 books, NCRT, RS Agarwal. So I have good grasp of machine in class 9, and then I've gone to the class 10. So understanding, and I don't say that is if someone is juggling means. If he's juggling, let's assume there is 24 hours in a day. Let's assume there's 24 hours in a day, and let's say he attends the school at, let's say, from 8 to 12, my school timing. Then from 8 to 12, and then he take the break of 12 to 4, and maybe he take the break. He can do the homeworks, whatever you want to do, whatever he wants to do. I'm saying under 10, not 11. 11 is we have they have to do the JE, so they can do under the 1 to 4. They can do that, and what I do is whatever the homework, if I attend a school, so the homework from there, then it start from 4:30 to kind of, if you have passion, you might have interest a lot. So from 4:30 kind of a go, because I started from kind of a, if I have school the next day, so I complete the kind of a from to morning 9:30 to kind of 11 o'clock, means kind of not learning every time, just making projects, talking with someone like this, so like that 1 hour from kind of making fun of that. So in that way you can do. But if I specifically talk about if I'm preparing for JE, IIT, it totally depends upon kind of a thing. Like I want to go that definitely in IIT, mainly IIT. So I was kind of asking recommendation from Tishme, which is who is an IIT Bombay, who has passed away from 2012, graduated from IIT Bombay. So he told that you don't need just now preparation. It is only you are in class 9. Just go with the books, whatever is teaching, whatever is being teach or taught in your books, and eventually then try out it's your my book. So I say that juggling is not that kind of till now. I would juggle at the point where 5 days my school was in exam. So there the 3 hours of exam are there, but I have completed in around 1 hour, because it's all MCQ. You have to just take it out, and I have to sit down around 2 to 3 hours on the bench, handing down, etc. I didn't like that. My backbone was kind of stuck at that point, so I didn't like when going at the school, heading down, and the teacher beats also, because if you're not heading down, so that was the problem when I was juggle at my school at that point.
Yeah, got it, got it. So kind of everyone shares a kind of difficult situation to juggle with, and it all depends like how much time allows. But definitely don't be forceful on you. Like Prashans told, like don't be forceful that I have to do it anyway. So keep your health and mental health at the top, and then try to see like if things go and go. So it's like just a closing question. How have been your journey with coding? Any suggestion around coding? Because let's say seeing you folks, multiple folks have come together like, okay, coding, let's start with coding. So it's like short, like let's say 1 minute, a 1 minute answer from both of you. Like how have been your journey into coding and your suggestions around coding? Like Ayush is definitely like data structure, so like he definitely goes in depth. So
Yeah.
I
Okay.
will just start with him. Yeah, 1 minute and kind of.
Okay, so kind of obviously DS and algo is required in machine learning, because mainly in NLP you require autocorrect kind of thing. So data structures and algorithms, are required if you want to go in any domain. And someone asked me that, hey Ayush, what is required in DSA in data science or DSA? Kind of they tell that the DSA is only required for kind of a placement purposes, but it's not. Actually, the companies are using. I've seen data science workstation uses that kind of thing. Means kind of I would say that data structures and algorithms. So I had also learned data structure mainly from the books, algorithmic design. I think so. Yeah. And there's two more books. I'm not remembering the name because a long name, but I remember the author name. So algorithm is ED by Java in Java, then algorithm kind of a design. So there is all available as a PDF. So I download a PDF because I don't want to. I want to read from kind of a paper, but it's kind of financial problem. So at that point, but now I have all the available books. I can code it along my computer. So it's kind of a okay. I'm comfortable with my PDF version. I really don't want to head over to the paper because someone said that okay, you can. It's kind of a different feel of doing onto reading from paper. But I think it is the same feel what I read onto my computer. So I think, and for coding suggestion to you, for anyone who is just watching, coding is not means and choose any programming language to choose, build your logic and computational power to solve the particular problem. As he asked the question kind of a thing, means Aeon has asked the question, means kind of a problem statement. So I was kind of I was not at that point three. I think he has said three. I will definitely solve that problem because I learned the thing whatever and use the Feynman technique and try to solve a lot of problems because whatever I've done till now, recursion kind of thing, linked lists, stacks, queues, and time complexity, I've ever solved more than 600 problems on maybe the concept. But I have to complete that, and then I will start joining the contest of the code chef. And I think in mainly in 5 to 6 months, or in the 7 months, or maybe in the year, I'll be fully planning to get into the 5-star coder at code chef.
Got. It's a like all the best for you or on that journey. And if we can be of any help, definitely let us know. Like closing with Prashans' point, like how have been your journey into coding, and like maybe you also have a computer science subject in your class 11th, 12th. I hope so as an additional. So like how have been your journey around that, because you started before actually that subject came into picture. So like how have been your journey, and we will close that event keeping in mind the times that we have allotted.
First of all, like many people come to me and ask like how we can start with data science and like with Kaggle. So I want to mention that many of them are afraid not of the actual thing what data science and machine learning is, but actually they're afraid of those very complex terms and all that stuff and the maths part of the data machine learning. Also, like if you're consistent, you are having that passion, so you will definitely it will keep you up on the point. And also, like success is not a
Smooth process kind of
constant
thing.
stop. So like success is the sum of all the small efforts repeated. So that's what I have for suggestion.
Got it. So thank you both of you for being an inspiration to all of us. Like at least it's like Ayush told, like why should someone cry that oh my god he's a 13-year-old and he's doing so much. It's like we should utilize that these two folks as a inspiration kind of stuff. Like if they can do, definitely a 10-year student or even a 22-year-old student or a 42-year-old professional can definitely do. So that's one of the biggest inspiration that we take from both of you. And thanks to both of you for joining us and giving us your time. And I know juggling juggling matters. So like yeah, definitely keeping aware of your time. So thank you for joining us and stay safe. Bye bye.